Hi everyone. Today we continue our conversation about factoring, and we're going to talk about factoring by grouping. Factoring by grouping is kind of a tool that you really want to have at your disposal whenever you see 4-term polynomials or whenever you see 3-term polynomials where the a value is not equal to 1. In some of our last lessons we talked about factoring when a was equal to 1. We talked about finding the magic numbers and inserting those numbers into binomials. But today we're going to talk about factoring 4-term polynomials and 3-term polynomials when a is not equal to 1. So our essential questions are just that. How do we factor? Four-term polynomials and the second essential question is, how do we factor polynomials where a is not equal to 1? And that is the not equal to sign. It's the equal to sign with the slash through it. Remember that a is referring to a in standard form of a polynomial, so ax squared plus bx plus c, we want it to equal 0 or we want it to not equal anything. And the a that we're talking about is that coefficient right there of the x squared term. It's the leading coefficient of a trinomial. So if I'm factoring by grouping for a 4-term polynomial, first thing I want to do is try to factor out the GCF. So let me move this up. There we go. Factor out the GCF first. So I think I mentioned in one of my last videos that you're going to see that that's a common theme, is that the first thing you want to do is check for a GCF. It makes your terms much more easy to manage because the coefficients get smaller. And so you want to factor out a GCF at first if you see one. Then you want to break your 4-term polynomial into 2 groups. The first 2 terms and the last 2 terms. You want to factor a GCF out of each pair. And the binomials in the parentheses, whatever is left over after you take out the GCF of each pair, they have to be the same. Because that binomial in the parentheses is going to become one of the binomials when you factor your polynomial. Be careful, if the sign in front of the 3rd term is negative, you must factor out a negative. Now I know as I'm reading these that without an example it really doesn't make much sense what I'm talking about, but whenever we see number 1 and number 2 done out, then you'll be able to see what we're talking about with the 3rd term being negative. You want to factor out the parentheses. This is one of the factors in your final answer, and put what's left over into a new set of parentheses. You can always check by foiling or using box method. You can always check your answer. So even before you submit your assignments, you can check to make sure that you got the right answer. Okay. So let's look at example 1. We want to factor completely. This is a 4-term polynomial. So there's 4 clusters of coefficients and variables that are separated by addition or subtraction signs. So first thing I want to do is see if there's a GCF I can take out. My coefficients are 8, 12, -10, and -15. And other than 1, they don't have any common factors that you can divide by. They also don't share a common variable for all 4 factors, so there's no GCF to be taken out. Next, I want to break this into 2 groups. So the first 2 terms make up the first group, 8xy plus 12y. And the second 2 terms make up the second group. Now, I do want you to notice something. If there is a minus sign here, then whenever you make your second group, you need to put plus, and then this minus sign needs to go inside of the parentheses to make this a -10x minus 15. And the reason why, and I'll erase this in a moment, so don't write what I'm writing in red, but the reason why is if you were to have written 8xy plus 12y minus, and then in this set of parentheses, 10x minus 15. We've talked about what it means to have a minus sign outside of parentheses, and that means you should distribute to every term inside of the parentheses. So this would have been minus 10x, which would have been fine, but then if I distribute the negative to the negative 15, that would have been plus 15, and that's not what we have here. So including that negative sign inside of the parentheses and having a plus join the two sets of parentheses, that's what you want. You don't want the negative sign to be outside of the parentheses. So just an example of something that you should not do. Let me go ahead and erase my red. There we go. All right. So step 2 was to break into two groups. I've done that. Group 1 and group 2 are both in parentheses. I want to factor out a GCF of each pair. So of this first pair of terms, 8xy plus 12y, I want to factor out its own GCF. So 8 and 12 are both even, so they're divisible by 2. Even more so, they're both divisible by 4. And if I look at the variables, the first term has xy, the second term has y. That means that they both have a y that they could give up. So the 4y comes out, and what's left over remains in parentheses. 8 divided by 4 is 2. X remains, and y divided by y becomes 1, so we don't write it. Plus, 12 divided by 4 is 3, and the y is divided out. So y divided by y is 1, we don't write it. Next group. I want to take out the GCF that belongs to this group. Notice here that in step 4 it says be careful if the sign in front of the third term is negative, then you must factor out a negative. So I'm going to have to factor out negative something. It could be negative 1 or it could be negative something else. 10x and 15 both have 5 as a common factor. So it's negative 5 that I'm going to take out. So negative 10 divided by negative 5 is 2, with the x remaining. And negative 15 divided by negative 5 is positive 3. The binomials that are in the parentheses must be the same, and they are. They're both 2x plus 3 and 2x plus 3. So now I'm going to factor out the 2x plus 3. That's one of my binomials. And then what remains is my second binomial. So 4y and minus 5 make up that second binomial. And this is my final answer. My final factored form. Now if I chose to, I am welcome to do FOIL and I could get my original problem back. So FOIL would allow me to see that I got it right by producing my original problem. Okay, so let's look at number 2. First step, factor out a GCF if there is one. So 36, 60, negative 9, and negative 15 are all divisible by something other than 1. What are they divisible by? They're all divisible by 3. So I'm going to take out a 3. For the variables, we have x cubed, x squared, x, and no variable at all. So that means that they can't all give up an x, so 3 is just my GCF. 36 divided by 3 is 12, x cubed. 60 divided by 3 is 20 with an x squared. Negative 9 divided by 3 is negative 3 with an x. And negative 15 divided by 3 is 5. Now this 3 is still part of my problem. However, it's just going to sit outside and not do much of anything for a while until we write our final answer. Our next step is to break this 4-term polynomial into 2 groups. So try to do that. Pause your video and see if you can break this up into 2 groups. Did you remember about the negative? That negative needs to go inside of the second set of parentheses, which means that you need to add those two sets of parentheses. We can't put nothing there. There has to be an addition sign. Otherwise, that would mean that we're kind of foiling, and I don't want to do that. That's not what the problem is asking. So now, what's our next step? What do? We have two groups. We want to factor out a GCF in each group. So 12 and 20 are both divisible by 2. They're also both divisible by 4. And we have x cubed and x. So each term can afford to give up an x, meaning 4x is the GCF. And what remains is 3x squared and 5. Now, as I'm writing this, I'm looking ahead at what my next GCF will be and then what will remain, and I notice that I've made a mistake. Does anybody see it? I've made a mistake here. This should be 20x squared, and here I just wrote plus 20x. Should have been plus 20x squared, which means that in the GCF, if I had x cubed and x squared, that means that there was x squared to give up in the GCF. My first term, instead of being 3x squared in those parentheses, should have just been 3x. And my second term should have been plus 5. So when I find a mistake, I need to follow through the rest of my work and see where it carries and what's changed. So now when I look at my second set of parentheses, I see that there's a negative here, so I need to at least divide out a -1. 3 and 5 have no other common factors, so -1 is what I take out. And what's left over is a positive 3x and a positive 5. And all of this still has, pardon the pop-up, all of this still has the 3 sitting outside as the original GCF to the problem. So finally, I have the 3 out in front. The 3x plus 5 makes up one of my factors. Sometimes we call these linear factors because the x has no exponent. And then the remaining pieces, the GCFs, make up the second factor. So 4x squared minus 1. Now typically this would be where we stop, but I do want to show you something that happens in this problem that does not happen in all problems. This 4x squared plus 1, that 4x squared plus 1 is the difference of two squares. So 3 is a factor, 3x plus 5 is a factor, but then if I square root 4x squared, I get 2x, and if I square root 1, I get plus or minus 1. Ooh, hang on. There we go. So truthfully, there are 4 factors here, and this does not happen on every question, but it's good to see an example of when it does happen, and identifying that 4x squared minus 1 is, in fact, a difference of two squares. It kind of tipped me off that there was a square there, an x squared, because that means that I might be able to break down that factor a little bit more, because I do want my factors to be linear and not have any exponents. Okay, so what I'd like for you to do is pause your video and try number 3. Check back when you think you have the answer. So check each step with my work for number 3. Notice that you should have split the 4-term polynomial into 2 groups. There's a plus sign separating them. You should have taken out GCFs of each group. The first group's GCF was an x, and the second group's GCF was a 2. What remained was in this line, the x squared plus 4 and the x squared plus 4, which became its own factor here. And the GCFs make the second factor, the x and the plus 2. Now, perhaps you didn't see this, but perhaps you did after the conversation in number 2, that x squared minus 4 is another difference, so subtraction sign, difference of 2 squares, the x squared and the 4. So that can be broken up into x plus 2 and x minus 2. And of course, multiplied by that other x plus 2. So you can write your final answer as those 3 binomials. You can also take the x plus 2 and the x plus 2 and write them as x plus 2 squared times that x minus 2. So that is another option for your answer format. So the last one is number 4 in this section, and number 4 looks kind of crazy, but number 4's method is the same. So if we can apply our steps to something that looks as goofy as this, then that means that we probably have this process down. So first step is to look for a GCF. 24, 18, negative 32, and negative 24 are all even, so they can at least be divided by 2. But think about what else they could be divided by. 2 is certainly part of the GCF, but they all also share the pound symbol, or you may know it as the hashtag. Not all of them have an exclamation mark or a square or a triangle, but they all have at least one pound symbol that they can give up. So 2 pound is the GCF. And 2 pound is going to come out in the front, just like all GCFs do. So 24 divided by 2 is 12. If I decrease this exponent by 1, because I'm dividing out pound to the power of 1, that's pound squared. And I have an exclamation mark. Plus 18 divided by 2 is 9, with a pound left over and a triangle. Minus 32 divided by 2 is 16. Left over with a pound, an exclamation mark, and a square. And then finally, minus 12, square, triangle. Okay. So I still have 2 pounds sitting out to the side, applied to everything, but now I need to make my 2 groups. So 12 pound squared exclamation mark plus 9 pound triangle. There is a subtraction sign here, so I need to add a negative 16 pound exclamation mark square minus 12 square triangle. Okay, so I'm going to let you kind of finish writing, check and make sure that you have everything that should be in your problem. Problems like this especially, sometimes little pieces get overlooked and you miss a triangle or a square or an exclamation mark because they're symbols and they're not numbers and variables that you're used to dealing with. So take care to make sure everything is the way that it's supposed to be. What would the next step be? Well, you want to divide out GCFs of each pair. So 2 pound stays out in the front, but 12 and 9 are both divisible by 3, and both terms can give up another pound. Ooh, sorry about that. Okay, so 3 pound sits out in the front. What's left over is 4 pound exclamation mark plus 3 triangle. Second group, GCF that can be taken out. There's a negative here, so I at least need to take out negative something. 16 and 12 are both divisible by 4, and I can take out a square. They both have a square that they can give up. So negative 4 square is the GCF. What's left over is 4 pound exclamation mark plus 3 triangle. Notice that 4 pound exclamation mark plus 3 triangle is the same. So that's one of my factors. 4 pound exclamation mark plus 3 triangle. The GCF makes up the other factor, so 3 pound minus 4 square. And the original GCF needs to be part of my factors out at the front. Whew. That was definitely an exercise in knowing the process. If you are unsure of what the process is, I urge you to go back and look at those beginning steps and try some problems again off to the side without looking at the ones we already completed. Okay, so let's look at this next group of things in our notes today. It answers the second essential question, which is how do we factor 3-term polynomials when a is not equal to 1? So first step, factor out the GCF. You want to find two numbers that multiply to equal a times c and add to equal b. What does that sound like? We're finding the magic numbers. We want to rewrite the middle term as 2 terms using the numbers that we found in step number 2, the magic numbers, and then you factor by grouping like you did in the previous problems. So we have an example. Notice how the a value here is equal to 2. It is not equal to 1. So we find our magic numbers. The two numbers that multiply to give us 2 times negative 21 or negative 42. That would be negative 7 and 6, and they add to give me negative 1. So negative 7 and 6 end up being here and here. And the way you determine the type of term is to look at this middle term. So this middle term is an x term, which means negative 7 and 6 are both accompanied by an x. So now you follow the model from previous problems and you factor by grouping. So you have a group of 2x squared minus 7x and a group of 6x minus 21. So when I factor out a GCF here, I can count on taking out an x. So 2x is left over and minus 7 is left over. Here I can take out a 3, a positive 3. So what's left over is 2x and a minus 7. The 2x minus 7 is the same in both pieces, so I can factor that out, and the GCFs make up the remaining factor. So it is very similar to the previous set of problems. Okay. So let's look at number 2. What do I always check for? A GCF, which in this case does exist. Is it 4? No, because 14 is not divisible by 4. But we can take out a 2. Look at the variables. I've got a's and b's. Here this has 4 a's, 3 a's, 2 a's. So they all have at least a squared that they could give up. This has 1b, 2b's, 3b's. So there is at least 1b that they can all give up. So 2a squared b is my GCF. Go ahead and write what remains. I'll pause my video, you pause yours. So check to make sure that you have all of your variables right, your coefficients right, your exponents right. We have a 3-term polynomial. We want it to be a 4-term polynomial. So off to the side, I'm going to find my magic numbers. I need 2 numbers that multiply to give me 6 times 2, which is 12. And those same 2 magic numbers need to add to give me my b term, which is negative 7. So numbers that multiply to be 12 are 1 and 12, 2 and 6, 3 and 4, and then they repeat. The pair that matches is 3 and 4. However, 3 plus 4 does not equal negative 7, it equals positive 7. So I need to make both of these negative. And negative 3 times negative 4 does still give me positive 12, so that works out. So whenever I write my 4-term polynomial, I still have 2a squared times b as my GCF. But now I have 6a squared, and instead of minus 7ab, I have minus 3ab and minus 4ab, because together that makes minus 7ab. So there's my 4-term polynomial, and now I get to factor by grouping. So 2a squared b still hangs out. I split this into 2 groups. Remembering that the negative needs to belong to the 4ab and not to the entire second group. And then I continue taking out the GCFs of each group, forming my 2 binomials and including my original GCF in my answer. So I'm going to pause the video and let you finish. Check your answers when you are done. Number 2, the first group, you can take out 3a. The second group, you can take out negative 2b. What remains in both cases is 2a minus b, here and here, which becomes one of your factors. The original GCF still sits out in the front, and the GCFs of the 2 smaller groups, 3a and minus 2b, make up that second factor. Okay. So for number 3, we've got 2 more questions. For number 3, I'm going to do it with you, and then for number 4, I'm going to ask you to do it on your own. So for number 3, check for a GCF. The leading coefficient is negative, so I at least need to take out negative 1. There's no other GCF that I can take out, though. So negative 1 sits out in front. We have 8x squared plus 14x plus 5. I need the magic numbers to make a 4-term polynomial, so I need 2 numbers that multiply to be 8 times 5, but they need to add to be 14. Oops. The 2 numbers that do that can't be 1 and 40. They can't be 2 and 20. 3 is not a factor of 40. 4 times 10 would work. 5 times 8 would not work, and that leaves nothing else to be written as factors. So 4 and 10 are my magic numbers. I'm going to use them to rewrite my middle term, and it's an x term, so it's going to be 4x and 10x that I replace that term with. I'm going to split this into 2 groups. So the first group is 8x squared plus 4x. The second group is 10x plus 5. In the first group, I can take out a 4 and an x. So that leaves me with 4x out in the front and 2x plus 1 left over. In the second group, I can take out a positive 5. So I have plus 5 times what's left over, which is 2x plus 1. My negative 1 still sits out as my original GCF. 2x plus 1 is my shared factor. And then the leftover GCFs make up the second factor, 4x plus 5. You could have also written this without the 1 here and just the negative, and that would be completely acceptable. Finally, last problem. Pause the video and try to finish number 4 on your own.